Okay. Today we are going to proceed with seeing some more examples on deterministic finite automata, right? So already we have some examples. Now we can discuss with examples. Okay, so now we are going to first start with the simple one finding. Let us consider so it is going to be the input symbols, right? This is the input symbol. So here we are going to consider for all the further examples, this will be the input symbol. Okay, alphabets, input alphabet. So here we are going to design the finite automata which accepts the language where the length of the string is at most 2. Okay, so please listen to the question. DFA, length of the string. The DFA is designed to accept the language which has the length of string at most 2. Okay, at most 2 in the sense, what is the meaning? I can have a string length of 0, string length of 1, string length of 2. Okay, so let me give you a minute time. So please do try it out. We can see the solution now. Okay, so length of string at most 2. Okay, let me repeat. Please don't join the meet and be idle. So please do work it out. Okay, so please do work it out. You should have the practice of designing the finite automata. Only then you can do it during the exam. Right. Okay, hope you have tried. Right. So here, what is the thing? So here I can have epsilon. Possible strings of the language is epsilon. So epsilon, the sense the length of the string is 0. So I can have A, I can have B, and then I can have AA, AB, BA, BB. Right? All these are accepted strings. So how should I design my finite automata? So here, this is my state, start state. So here you can see I have to accept the empty string as well, right? I have to accept the empty string as well. So this will be my final state. Okay, start state will act as my final state. So of this here you can see epsilon will get accepted by this finite automata. If suppose this is a finite automata, then this will be accepting epsilon. Next comes I have to update my finite automata to accept A. So if suppose A comes, then it should be accepted, right? So then it should be accepted, right? If suppose B comes, right? I am mistaken now. If suppose B comes, then also should be accepted. Okay, so B would be accepted. So the next I have to design the finite automata to accept two keys, right? So here you can see the next A comes, then I have to move the final state, then we call this as Q2, right? So here, my kind of mechanism will accept AA, it will accept B, it will accept A, it will accept B, it will accept epsilon. Now I have to proceed with accepting BP, right? So here one B comes, so I am state Q1. If Q1, if suppose I am coming across now, then it will be accepted. So after that, if suppose I am, so here is this a valid string? No. Is this a valid string? No. Right? So here I have to reject it, right? So if suppose on, so let us consider this one, right? So after when I'm in this position, I can state Q2, right? In Q2, I'm coming across B or I may come across B. So what I have to do, I have to move on to a trap state that we call that as Q. Okay, or let me move on to trap state. After that, whatever comes, I'll be in the same trap state, right? Are you clear with this one?
Yes, ma'am.
Yes. Okay. So the next what you are going to try is um, design a finite automata for a language of strings exactly. So the strings should have exactly 2 A's. Okay. So please listen. The strings, all the strings of the language should have exactly 2 A's. Not length of the string is 2. So here, what the length of the string can be anything, but the number of A's in the string should be exactly 2. Okay, try it out. So you have tried, right? So what is the thing? Exactly there should be 2 A's, right? So what are the possible strings? I can have A, I can have B, A, B, I can have B, A, B, A, right? I can have B, 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 A, B, 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 B. Likewise, it goes on, right? But the thing is that I should have exactly only 2 A's, right? So first I have to design the finite automata to accept this. So this is my start state, right? If one A comes, I will move to another state. Let me call that as Q1, and another A I'll be reaching the final state, right? I'll be reaching the final state. Okay, you can call this as Q2, right? So if suppose VAA comes, so whatever may be the number of V's comes here, it should be the same state, that is Q0. Similarly, after one A, so here I can have any number of V's, right? So here, sorry, any number of V's can be present with this string. Okay, so any number of V's is possible. So here, yeah, if B comes, I'll be in the same state Q1. And similarly, after this A, if suppose a B comes, I'll be in the same state Q2. Right? So because this is also a valid string. So what about this one? Is this a valid string?
No.
So
No,
what
ma'am.
should I do? To move on to the trap state, let me form that as Q3. Right? After that, whatever comes, it will be in the same trap state. Is that clear? Shall we proceed further?
Yes, ma'am.
Now we proceed with at least 2 A's. At least 2 A's. Please see the difference. There are exactly 2 A's. Here, at least 2 A's. Here, in this case, if this is valid, this is valid, this is valid, this is valid, this is valid. What about this one? Is this a valid string of this language? This is a
Yes, ma'am.
valid string. Yes. Yes. According to design the finite automata. Okay. Right. The same thing. So till this point, it is going to be the same thing, right? So here, if one A comes up here, let me repeat, at least in the sense I can have AA, I can have BAA, I can have BABA, I can have BABA. Everything is possible, right? So here I should have at least two. So one A. So only if two A's are there, I can reach the final state, right? Okay. I am in final state, that is Q2, right? So here, if D comes, I'll be in Q naught. So that is I am in state Q naught. If D comes, I'll be in the same state. So maybe I am in Q1. If whatever maybe the number of D comes, I'll be in same Q1. And similarly here, in Q2, whatever may be the number of D's comes, I'll be in the same state Q2. What about A? If A comes, what should I do? Here in Q2, I am coming across a A. What should I do? Where should be my transition?
Same Q.
Yes, good. Yes, it will be in the same state here. Right. Now try with at most 2 A's. At most 2 A's. Please first list out the possible strings of that language and then you try. At most, in a sense, I can have 0 A's, I can have 1 A, I can have 2 A's, right? Maximum of 2 A's are possible. 0 A's also holds good. So here, what are the possible strings? So here, yes, the epsilon is possible, right? So please make a note in the previous two cases, though the count of D is not mentioned, count of A is mentioned, right? At least two should be there. So the length of the word will be at least two. Length of the string will be at least two, right? And in this case, the length of the string, yes, the minimum possible string length will be two, right? So here it is going to be at most 2 A's. The restrictions with regard to B is not given. So B can be epsilon, right? Number of B's can be 0. So epsilon is also a possible string. And next is A is possible. A is possible. BA is possible. BA is possible. Likewise, it goes on, right? Okay. So let us proceed. So here, yes, the empty string will also be possible, right? So here, whatever next comes 1A, so that there can be a maximum of 2A's. So if there is no A's at all, then I am in the final state. If there is 1A also, I should be able to reach the final state. And if there are 2A's also, I should be able to reach the final state. Right? So I should be able to reach the final state. Right? So here I can have any number of these, with any number of these and any number of these, right? Okay. So here, is this a valid string?
No, ma'am.
So what should I do? So here I am in this state Q3. In Q3 I'm coming across me. What should I do? I have to move on to a trap state. Let me call that trap state as Q4. So after that, whatever number of A's and B's comes, I'll be in the trap state. Are you clear with that?
Yes, ma'am.
Okay, so this is next 2 years. So the next one we are going to proceed is the length of the word mod 2 should be equivalent to 0. Okay, so the length of the word. So here already we have discussed length of the string is represented by the symbol, right? So here length of the word is represented. So length of the string is represented by this one, right? So length of the string mod 2 should be equivalent to 0. So what is the meaning? So I can have, that is I can have a string length of 0. I can have string length of 2. I can have a string length of 4. I hope you are aware of mod operator, right? So what is the resultant of mod operator? It gives you the reminder, it will uh, uh, that is in the case of division operator, it will give you the quotient, right? So here mod operator will give you the remainder. Is that clear? So the division operator will give you the quotient and mod operator will give you the remainder. For example, 5 mod 2, right? It will return the remainder of 1. Okay. 6 mod 2 will return the remainder of 0. 6 mod 4 will return the remainder of 2. Are you clear with this? Is that clear? Are you clear with this mod operator?
Yes, ma'am.
Yes. Right? So 6 divided by 4, if you perform, you will get the remainder as 2, right? So that is going to be the resultant of this mod operator. Remainder will be returned as the resultant of mod operator. Okay, so here the question is, this length of the string, length of the string mod 2 should be equal to 0, right? So all the strings of that language should be having a length mod 2 as 0, right? So how to design, try designing the finite automata for that. So please make a note. Here again, as discussed, the input symbols are A and B. So already I have told you that. So what are the possible strings? So first we have to list out all the possible strings. So here, if string length is 0, then 0 mod 2 is 0, right? Okay, so the length can be 0, length can be 2, length can be 4, length can be 6, likewise it goes on. Okay, try with that one. Okay. We will have tried. So as discussed, so what is possible? Epsilon is possible. A is possible. AB is possible. A is possible. BB is possible. And then AA is possible. Likewise, it goes on. Okay. So similarly, AA is possible. Okay. Here we can start with, as said, epsilon is also possible, right? So, yes, empty string will be accepted, right? The empty string will be accepted. Next thing is that the DFA should accept this. DFA should accept it, right? So if A comes and be in state Q1, another A comes and be in state Q2, which will be the final state, right? Which will be the final state. Okay. So if suppose another A comes, where should we make transition? I am in state Q2. In Q2, if suppose an A comes, so for example, A. Okay, A. Right. So here, where should we make transition?
Q1.
Yes. Yes. Good. So here, where should we? So here, I should have the transition to Q1. So please see, listen here. Here, what happens? So here, similarly, if B comes, I'll be here, and similarly here B comes, I'll be in Q2, and if B comes, I'll be in Q2. Okay, so here you can see, if suppose BA comes, this is a valid string, right? So this is a valid string. So what happens? I am state Q0, and Q0 I'm from cross A, so I'll be moving on to Q1. So here Q1, in Q1 I'm coming across B, yes, Q2, in Q2 I'm coming across B, so Q1, in Q1 I'm coming across A. What happens? I'll be moving on to state Q2, which is the final state, right? So which is the final state. If suppose there are two A's, right? So two A's are, so let us consider this one, right? So I am in state Q2, in Q2 I'm coming across B. So where I'll be moving on to Q1, where the string is over, right? So when we will call that as a accepted string, so I should be able to start from this for the entire string. From the start state, I should be able to reach the final state. Okay, or I should be able to reach the final state, right? So here you can see this string is not getting accepted, right? I am in the state Q1. Or is that clear for you? Or should I repeat?
Ma'am, could you repeat?
Okay, so here, do you agree with this set possible strings? This possible
ma'am.
string is there, right? Okay, let me proceed with. So here, yeah, epsilon should also be accepted. So This is going to be my start state will act as the final state. So this is getting accepted. So what is the next thing? So AA should be accepted, right? So AA should be accepted. So I have to design the finite automata to accept AA. Okay. So I am defining the finite automata to accept A. Yes, accepted. I have to update the automata to accept AB, right? So I am in state Q1. In Q1, I am coming across B, right? So QB, yes, fine. So next comes BA. BA should be accepted. I have to update it appropriately. So I am in state Q0. In Q0, I am coming across B. Yes, moving on to Q1. In Q1, I am coming across A, moving on to Q2. Next is BB. Yes, already it is there. Do you agree with this?
Yes, ma'am.
Yes. So the next comes this one, right? So here I am in this position. So here I am in state Q2. In Q2, I am coming across A. So where should be my transition? After that, I should have
Q1.
yes. So please make a note over here. I should have the string length of multiples of 2. Okay. String length in a multiples of 2. So either I can have 0 or 2 or 4, 6, 8, 10. Likewise, it goes on. Right. So what should I do? I should move on to the state where I can make sure that condition is met. Right. So where should I make the transition? So here I am in state Q2. So I can have what are the possibilities I can have? I can have AA, I can have EA, I can have EA. All these are possible, right? All these are possible, right? So if A comes, I should make the transition to state Q1. Similarly, if B comes, I am in state Q2. If B comes, I should make the transition to Q1, right? So here, let me check with this example, right? So here I am in state Q0. In Q0, I am coming across A, so we want to Q1, right? So here Q1. In Q1, I'm coming across A, so move on to Q2. So here Q2 coming across A, move on to Q1, right? In Q1 coming across me, move on to Q2. So here A, I am in Q2, coming across A, move on to Q1. In Q1, I'm coming across B, move on to Q2. I have reached the final state. Is that clear? Yes or no? Shall we
Yes, ma'am.
proceed further? Huh?
Yes, ma'am, it's clear.
Yes, good. Okay. How about others more? Are you all comfortable with this? Why? What happened? This much silence. Shall
It's
I
fine, ma'am.
proceed? Huh?
Ma'am, you can proceed.
Yes, thank you. Okay, so here this is an automata, right? So for this, we can go for designing a minimal automata where we can reduce the number of transitions as well. Okay, so here you can see this is Q1. Okay, so what is required? I can have some the strings of length multiples of 2, right? So if suppose A comes or B comes, I'll be in state Q1, right? If suppose an A or B comes, I can move on to the final state, right? So A or B comes, I can move on to the final state. Do you agree with this? So please listen here. If A or B comes, I'll be moving on to for first A, I'll be moving on to Q1. For next A or B, I'll be moving on to state Q1 or Q0, right? Q0, which is the final state, right? Final state. And next, if suppose A or B comes, I'll be moving on to Q1. And the next is simple, I'll be moving on to Q0. Do you all agree with this?
Yes.
Yes. So this is the minimized DFA for this one, right? Okay. Now try to design the DFA for mod 3. Mod 3 is equal to 0. Yes, mod 3, yes. So here in this case, the string length can be 0, 3, 6, 9. Likewise, it goes on. So please will try it out now. Yes, it's a very simple one, right? So yes, so here 0 is possible, 3 is possible, 6 is possible, 9 is possible, right? So here, so for multiples of 3, I have to proceed with the designing the finite automata. If 0 is possible, yes, accepted. So if one A or B comes, I have to move on to the another state, that is Q1, right? So for first character of the string, I have to move on to Q1. For the second character of the string, I have to move on to 2, right? That is AA or AB or BA, whatever it is. I'll be in state Q2. So if, sorry, AB, is this a valid string? Is this a valid string?
Yes.
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 So where should be my transition? I'm in state Q2. I'm coming across E. Where should be my transition?
Q0.
Yes. Good, good, good. So for my third character of the string, I'll be moving on to Q0. Okay. So here you can check with this. Yes. I hope you will agree with this. This is also a valid string, right? This is also a valid string. So we can try it out with this. Yes. A, I am in Q1. B, I am in Q2. A, I am in Q0. Again, B, I am in Q1. For this B, I am in Q2. For this B, I am in Q0. Right? Are you clear with this one?
Yes, ma'am.
Yes. Okay. So now try to design the finite automata. Okay. So here now we are going to proceed with the designing the finite automata for number of A's, right? Number of A's in the string are divisible by 2, and number of B's are divisible by 2. Okay. A's are divisible by 2 and number of B's are divisible by 2. So what is the meaning? Number of A's in that word mod 2 is equal to 0 and number of B's mod, that is number of B's in that word, right? So number of B's in that word mod 2 is equal to 0. Two different conditions are need to be checked, right? So you know how to design the finite automata for this one and how to design the finite automata for this one. Do you agree with that? Say yes or no?
Yes, ma'am.
Yes, already we have seen, right? We have designed the finite automata, right? Okay. So here, the thing is that divisible by 2. So the number of A's divisible by 2. So first let me proceed with the designing the finite automata. Okay, you please first try to design the finite automata where number of A's in that word are divisible by 2. Okay, please do try it out now. So there are 2 A's should be there. The number of B's can be anything. 2 A's in the sense multiples of 2. Number of A's should be multiples of 2. The previous case we discussed with regard to the word length, right? Here in this case we are discussing with regard to the specific symbol in that word. Okay, so hope you would have tried, right? So here, yes, if the number of A's are 0, is good. Number of A's are 2, is good. Number of A's are 4, is fine. So all these categories should be accepted. Similarly here, right? So let me first construct this. So number of A's is 0 in the sense I should, that finite automata should accept the strings. The number of B's can be anything, right? The number of B's can be anything, right? Yes, if suppose one A comes, I am moving on to state Q1. If suppose another A comes, I'll be moving on to state Q0. Right? So here again, I can have any number of Bs. Do you all agree with this finite automata for this condition?
Yes, ma'am.
Yes. Similarly, for B, the same thing. So here, with respect to number of Bs, right? So, oh, yes, sorry. Okay, two different finite automata. Okay, so this is for this one, and then please make a note. Don't proceed with the same stage of the DFA because I am going to take a cross product of these two finite automatas, right? So go for some three different statement. Okay. So here Q2. So if B comes, yes, 0 B is accepted. If 1 B, then I have to move on to Q3, right? If another B comes, I'll be moving on to the final state, that is Q2. So here again, number of A's can be anything. Number of A's can be anything. Okay, so here we have designed the finite automata for these two separately. But what we have to do, we have to take the AND of these two, right? So A's should be divisible by 2 and B's should be divisible by 2. For that, we'll be taking the cross product of these two, right? I will be taking the cross product of these two. So how many states will be there in the cross product? So it is going to be the simpler thing. So here what I'm going to do is Q naught multiply, that is product, cross product of this cross product of this, right? So Q naught Q2, Q naught Q3, Q1 Q2, Q1 Q3, right? So if suppose, so let us consider how many states are here. In this case, there are 2 states here and 2 states in this DFA, right? So if I'm going to take the cross product in the final DFA, I'll be having 4 states. I'll be having 4 states. Right. If suppose there are 2 states here and 3 states here, how many states will be there in my final DFA? How many states will be there? Cross product.
6.
6. Good. 6. So in this example, we are having 2 in this DFA and 2 in this DFA. So cross product, I'll be having 4 final states. Okay, 4 final states. So 4 states in the final DFA. Right. So I'm going to construct the final DFA, which will have 4 states. Right, 4 states. So here, here, here. These are the 4 states. Right. So what is going to be my state here? So it is nothing but Q naught Q2. Right? Q naught Q2. So Q naught Q2 will be my state. And next comes Q naught Q3. Right? Q naught Q3. So this is Q3. And next is going to be Q1 Q2. Q1 Q2. And next state will be Q1 Q3. Right? Q1, Q2. Now, the state names I have mentioned. Now, what we have to proceed in? We have to assign the final states and the start state. Okay. What are the start states here? Which is the start state here?
Q naught,
Q naught. Here,
Q2,
Q2. Right?
Q2.
So here, yes, good. So here Q naught, here Q2. So which state is the cross product of these two? This is the cross product of these two, right? Q naught, Q2. Okay. So here Q naught is the start state and here Q2 is the start state. So this will be acting as the start state. And similarly with regard to the final state, this is the this is the final state and this is the final state. And cross product of these two will be acting as the final state. So similarly, this will be acting as your final state. Are you clear with this?
Yes, ma'am.
Yes. Okay, fine. So what we can do is we can continue because it will, I cannot rush it up. It will take some time. Okay. At least 10 minutes will be required. It's almost a time. So we can continue with this in the next class. Are you clear till this point?
yes, ma'am.
Yes. Right. Okay, ma'am. We can continue this in the next class. Okay. Let me join the attendance.